Hello students, welcome to Virtual Chemistry. This is Dr. Padmaja. Please subscribe to my channel. Let us continue today's topic, that is IUPAC nomenclature of simple alkanes and cycloalkanes, students. Today I am going to tell you what are the various rules that we have to follow while naming simple alkanes and cycloalkanes. Coming to the simple alkanes, the rules that you have to follow is, see here I mentioned all the rules. Find the name of the longest continuous carbon chain. First you identify, what you have to do students, first you need to identify the longest carbon-carbon chain. Okay, then after that you should identify is there any substituent attached to the carbon-carbon chain. And count the number of carbon-carbon chain, parent carbons, give numbering of carbons in such a way that the substituent group should, the carbon which is attached to the substituent should have least numbering. Okay, and designate the location of each substituent group by an appropriate number and name. Assemble the name. First, you have to start with prefix, that is substituent, followed by cyclic compound means cyclo, and then you have to write the parent chain based on the number of carbons. Okay, so let us discuss these rules in detail. I will explain with example, students. Okay. Okay. So what is the first rule, students? We have to see. In IUPAC, the naming will be in this way. Prefix plus root word plus suffix. Okay, so this order you have to follow. Coming to the simple alkanes, the first rule is you have to identify the longest carbon-carbon chain, students. For example, I gave this alkane. Find, write the IUPAC naming of this alkane. Okay. Okay, now you see, students, what you have to do. The first rule you have to follow, you should just count the longest carbon-carbon chain. See here, 1, 2, 3, 4. Or you can count in this way, 1, 2, 3, 4, 5. You can count in one more way, 1, 2, 3, 4, 5, 6. You understood? So if you count this one, only 4 carbons are coming. If you count like this, 5 carbons. But if you count in this way, we are getting how many total? 6 carbons. So this will be the longest carbon-carbon chain. So this will be a parent chain, students. First, you have to identify parent chain. How many carbons are in there? 6 carbons. Now the question is there any substituent in this? Yes, of course, we have a methyl substituent. What is the substituent name, students? Yesterday's class, in the previous video, I explained about substituent name. This is called methyl. This is called methyl. So identify the substituent and give numbering in such a way that this carbon, the carbon which is attached to methyl group, should get least numbering. So I can give numbering from left to right and right to left. Let us see. If I gave numbering from left to right, 1, 2, 3, 4, 5, 6. And the third carbon we are getting substituent. Okay, if I gave in the opposite direction. Okay, so right to left, 1, 2, 3, 4, 5, 6. And the fourth carbon we are getting substituent. What is the second rule, students? The second rule is that, so identify the substituent and see that the numbering of carbon, parent carbon chain should be given in such a way that substituent should get least numbering. So this is the correct one, student. This is wrong. So this method you don't follow. Now tell me the name, how to write the name. Here only we have one substituent. So first mention the carbon, number of the carbon. Third carbon we have, on third carbon we have methyl. So 3 methyl substituent. Then comes root word. So total 6 carbons. 6 carbons means what is the root word, students? Hex. 3 methyl hex. And these are only having single bond. Single bond means it is said to be ane. So hexane. 3 methyl hexane is the name of this particular organic compound. Is it clear, students? Okay. Here only 2 rules we implemented. Okay. And whenever there are more than one substituent, then what you have to do? Then also you have to check that carbons, when you add the carbon count, that way should give the least number, least value. Okay, and if they are different substituent, they have to be written. Their names has to be written in alphabetical order. Let's see few more examples, students. Okay. Second example I'm going to give you here. That is okay. Now write the name of this alkane, IUPAC naming. So what you have to do, first rule you follow, find the longest carbon-carbon chain. First rule, longest carbon-carbon chain. That will be the parent chain. So count carbons now. 1, 2, 3, 4, 5, 6. If I count like this, 6 carbons are coming. 1, 2, 3, 4, 5, 6, 7. So if you count like this, 7 carbons are coming. 1, 2, 3, 4. Only 4 carbons. And remember, students, this longest carbon-carbon chain, no need to be straight. No need to be straight. Okay, you can count anyway. No need to be straight. So now which one we have to follow? 6 carbons or 7 carbons? You have to take maximum number of carbons should be included. So 7th one is correct, students. Now let us give numbering. Here we have 2 substituents. See, on this carbon we have methyl substituent. Okay, on this carbon we have chloride chloro substituent. Then how to give the numbering, students? Let's see both possibilities. So 1, 2, 3, 4, 5, 6, 7. So if I do in this way, I'm getting second rule we are discussing now. So that is giving numbering to the parent chain based on the substituents. So here on the third carbon, we have a substituent. On the fifth carbon, we have a substituent. So total value is 8. So least sum rule. You have to always follow least sum rule. When you add these carbon positions, that has to give least value, students. And if you do on opposite direction, let us give numbering in opposite direction, students. Okay, so 1, 2, 3, 4, 5, 6, 7. Now you see here, in this case, again I'm getting substituent on the third carbon and on fifth carbon. So both are same. Both are same. So you can follow either of the method. So on the third carbon and on the fifth carbon. 1, 2, 3, 4, 5, 6, 7. Of course. So here you can follow either this way or this way. Just write the naming. Okay. So alphabetical order you follow, students, now. Say third carbon, chloro, and fifth carbon, methyl. So write the name. On the third position we have chloro, and on the fifth position we have methyl. 3 chloro, 5 methyl. Total 7 carbons. So hept, and all are single bonds. We are talking about alkanes. So hept chain. So this is the name of compound. Okay, clear? And let me give you one more very good example. Third one. Now try to answer the write the IUPAC naming of this one. First rule you follow, students. What is the first rule here? Select the longest carbon-carbon chain. See, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So what's the highest possibility? Or 1, 2, 3, 4, 5, 6, 7. You can take this one. Or 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Only two possibilities, students. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. You can take either of these. If I take this one, it will become substituent. If I take this carbon, this methyl becomes substituent. So let us take this as a longest parent chain. Okay, this is the longest carbon-carbon chain. First rule is done. So how many total carbons? 1, 2, 3, 4. First total 7 carbons have come in parent chain. Okay. Next rule is what, students? You have to give numbering now. You see what substituents we have? Two different substituents we have. This is a methyl substituent and this is an ethyl substituent. Methyl and ethyl. So let's give numbering in both the, let's type in both the ways. 1, 2, 3, 4, 5, 6, 7. So in this case, what is the value, students? 2 plus 4, that equal to 6. Next, reverse. 1, 2, 3, 4, 5, 6, 7. Now what are the positions, students? Substituent positions. On fourth carbon we have ethyl, plus on the sixth carbon we have methyl. So that is 10. See, least sum rule you have to follow. According to least sum rule, this is the wrong way of giving numbering 1, 2, 3. So don't follow this one. Only follow this one and write the name now. So what I told you, when we have more than one substituent, don't consider the number. Position of the carbon is not considered while writing the name. Only follow alphabetical order of its substituent name. Methyl and ethyl. Which will come first? Ethyl will come first. Even the number is more for this. No need to worry about the number. So 4 ethyl. On second carbon, we have methyl. 4 ethyl, 2 methyl, 6 total 7 carbons. So H and all are single bonds. In no functional groups. So 4 ethyl, 2 methyl heptane. Here you see, students, even first point of difference also. Here it is 2, here it is 4. So 4 is more, but 2 is less. So even that is also saying the same thing. Okay, next. One more example. Fourth example, we are going to discuss here. Let us take one example. Now, name this one, students. See, parent carbon will be 1, 2, 3, 4, 5, 6, 7, 8. Because it is a methyl, only methyl substituent you can take. This will be a parent carbon. So, now numbering, 3 substituents we have 1, 2, 3, 3 different substituents. Then what you have to do, numbering you should give. How to give numbering? Here, let me tell you. See, from this side if I start, give numbering. 1, 2, 3, 4, 5, 6, 7, 8. So on second position we have substituent, fourth position and sixth position together is 12. In reverse 1, 2, 3, 4, 5, 6, 7, 8. On third position we have substituent, on fifth position we have substituent and on seventh position. So 3 plus 5, 8, 8 plus 5, 15. So this is wrong. And even you see first point of difference is also saying the first method is correct. Now write the name. So write the name now. So while writing the name for substituent, you should follow alphabetical order. Chloro, bromo, methyl. Who will come first? Bromo. So which carbon it is having? On fourth carbon, 4 bromo. Okay. Next comes chloro. So next comes 7 chloro. Next is 6 methyl. Sorry, students. 2 chloro. 4 bromo, 2 chloro. This is 6 methyl. And total 8 carbons. So 8 carbons means octene. Single bond. So octane. That's it. Okay. So one more last example I will tell you. When more than one substituent of same kind is there, then you have to use the word like di, tri, tetra. So let me explain with one example. Let us take a carbon bonded structure, students. Write the name of this one. So the parent chain will be this, no doubt, because we have only one carbon-carbon chain here, not more than one. So numbering, how I can give? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from left to right. So 4 plus 7 is equal to 11. Reverse 1, let us review. 1, 2, 3, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so where we have again 1, 4, then 7. So they are symmetrically arranged. So you can take any one of the positions, students, no problem. So write the name now. There are two of same kind. I mentioned their positions 4, 7. So two are there. 2 means we have to use the word di. 3 means tri. 4 means tetra. So this di should not be considered while writing the names in alphabetical order. Okay, here we have only one. So dimethyl, 10 carbons means dic, and single bonds and again. Okay, and in the same thing compound, let us put here a chlorine. Okay, now tell me what is the name of this one. So I gave numbering as well. Now which one will be the correct order? So second position we have chlorine. So second, fourth position, and this order will be correct. This will be wrong numbering. So now tell me who will come first, chloro or dimethyl? Chloro will only come. So 2 chloro. Next is 4, 7 dimethyl decane. So like this, in a different ways, I explain students. I think almost all rules we covered. Find the name of longest continuous chain. Identify the name group attached to that. Numbered in consecutive way, starting nearest to the substituent group. And designate the location of each substituent group by an appropriate number and name. Next, assemble the name listing groups in alphabetical order. If they are more than one, use the words like di, tri, tetra, etc. Okay, clear students? I think I gave almost all examples related. Now let us see simple cycloalkanes. Okay, so now first example I'm writing here. Write the name of first one. Okay, now tell me which one we have to take. So here we have a cyclic ring and a straight chain. And just count which is having more number of carbons. See here we have 6 carbons, here only 4 carbons. So the longest carbon chain will be this only. So this is the longest carbon chain. So it will be, this becomes a substituent. What substituent it is, students? 1, 2, 3, 4. 4 carbons, all are in straight line. So N-butene, butane. So N-butane, normal name. So N-butanil, when it is attached, butane, butanil, methane, methyl, sorry, butyl, and butyl you take, and butyl. Okay, now write the name, students. So it's a, what is the substituent that it has? Give the numbering starting with first carbon. See, now we have a substituent which has to give a number 1 to that, then 2, 3, you can give in any way, 4, 5, 6, because it has only one substituent. If it has more than one substituent, again you have to see lowest sum rule. So on first carbon, what we have? On first carbon, we have a complex substituent, so it has to be written in brackets and butyl. Okay. Next, what we have? So whenever there is one position that no need to consider, then we have to add the word cyclo and butyl cyclo. Total 6 carbons, so hex, and all are single bonds ane, hexane. Clear? Okay, let us discuss few more examples. Second one. Now tell me what is the name of this one. Who will be the parent carbon-carbon chain here? Parent carbon-carbon chain will be this ring. Okay. So this ring will be the parent carbon-carbon chain, and these two become substituents. Here it is methyl substituent we have and a bromo substituent we have. Okay, fine. So now we should give the numbering, students. So if I start numbering, when you want to give numberings, more than one substituent, you follow alphabetical order. So give number 1 to this. Then if I start this side, it is getting number 4. If I start this side, it is getting 3. So give numbering in that way, where both substituent gets least value. Okay, this is the correct way. So give the name. Substituent 1 bromo, next 3 methyl, cyclo, total 5 carbons, pentane, cyclopentane. Clear, students? And one more example. Okay, write the name of this one, students. Try to write the name of this one. So here this will be a parent chain, and you have to give number. See, this is ethyl, this is chloro. Give number 1 to this, number 2 this. Okay, don't go this way. Then it comes 3. We can give in 2 ways. Same thing, we can write even like this also. 1, 2, 3. But here 1 plus 3. 1 plus 2 is equal to 3. Here 1 plus 3 is equal to 4. So this is the correct method. So don't follow this one. Now write the name. Okay. So 1 chloro, 2 ethyl, cyclo, propane, 3 carbons, so prop, and all are single bonds, ane, propane. Okay, so in this way you can solve any kind of questions based on those 5 rules. Same rules you can follow in this case, but you see, while giving numbering to the substituent, you have to follow alphabetical order, and you need to check even first point of difference or lowest sum rule, students, while writing a name for cycloalkanes also. Is it clear? Hope you understood everything. I hope it will helpful to you. If you really like my video, please subscribe to my channel. Thank you for watching.